This is a whole synthesis, and they gave us the products. All we need to fill out is the reagents that we need. So we start with benzene. Nothing to look at in here. We have to look at what we're making from benzene. And what we're seeing is that we did a Friedel-Crafts acylation reaction. And the acyl halide that we used, it's going to be this one right here. There's going to be a carboxylic acid hanging off of the other end, but we need a chloride attached to this carbonyl right here. So that's what we're going to draw. We're going to do the acyl halide on one side and the carboxylic acid on the other, which I'm going to put a CO2H. We also need aluminum trichloride for this reaction. It's a Friedel-Crafts acylation, so we do need a catalyst. And this is going to be the product right there. Remember that after you do this reaction, you need to do a workup so that you can protonate your carboxylic acid, get rid of the aluminum that's in there. All right, now, this is a ketone. This is a carboxylic acid. And what I need to do is that I need to reduce the ketone, the carbonyl of the ketone. And we know two reactions that can do that. They're not going to affect the carboxylic acid. They only do ketones on aldehydes. And we're going to use the Clemmensen reaction. And the Clemmensen reduction, we take an amalgam of zinc and mercury under acidic conditions. It's a reaction that's specific for ketones and aldehydes. It will not do anything to the carboxylic acid, so we don't have to worry about it. Now, the next step, we're taking this OH of the carboxylic acid and we're just converting it to the chloride. There is one reagent that can do that with no trouble whatsoever, thionyl chloride, SOCl2. And the only thing that it's going to do is substitute the OHs. Whether it's from a carboxylic acid or an alcohol, it will take the OH and convert it to the chloride. This one is now an acyl halide. And notice that what we're going to do is that we're going to use that acyl halide to close a 6-member ring right here. So what we're doing is a Friedel-Crafts acylation right here. And it's an intermolecular Friedel-Crafts because I already have my acyl halide attached once to my benzene. So all I need to add would be the aluminum trichloride, the catalyst for the Friedel-Crafts. And it will come and attack this carbon right here. Sorry, this carbon will attack the carbonyl. And that's it. It's going to be favored because it forms a 6-member ring. And 6 and 5-member rings are favored reactions.